Alright, so basically we're going to look at grade 11 trigonometry. And first and foremost, we will look at it in light of for RAT, in other words, a right angle triangle. We know that the definitions of trigonometry for right angle triangle are the following. We have sine, which is a trig definition, one of the basic ones, which is opposite of hypotenuse. Alright, we have cos, which is adjacent of hypotenuse. We have tan, which is opposite over adjacent. And if we move over here to the Cartesian plane, we know that sine on a Cartesian plane can be, in terms of x, y, and r, sine is y over r, cos is x over r, and then tan is y over x. Now, something to note is that on our Cartesian plane, we have what we know as the ASTC rule. In other words, for each quadrant that is in the Cartesian plane from 0, 90, 180, 270, and 360, which is actually in an anti-clockwise direction, we have in this first quadrant all trig ratios are positive. In the second quadrant, sine only is positive, whilst cos and tan are negative. Here, tan is positive, while sine and cos are positive and negative. And then cos here is positive, whilst tan and sine are actually negative. Okay. Then, moving really swiftly, we have what we refer to as function values. Our function values are just ways in which we use something we know as the reduction formula to be able to express angles as acute angles with their trig ratios, sine, cos, and tan. So if we look at sin 180 minus theta on the quadrants is actually situated in the second quadrant. 180 minus is situated in the second quadrant. That's where sine is positive. So in other words, sin 180 minus theta is in which quadrant? It's in the second quadrant. How is sine in the second quadrant? Sine is positive, hence the sine is positive. You write the trig ratio sine, you follow it up with the acute angle, whilst 180 minus falls away because of the determination of what the sine is in that particular quadrant. If we look at sin 180 plus theta, 180 plus theta is in the third quadrant. How is sine in the third quadrant? In the third quadrant, it's only tan that's positive, while sine and cos are negative. So their sine is negative. So 180 plus falls away. We assume the trig ratio, and then we write the acute angle. Then sine 360 minus theta. This 360 minus theta features in the fourth quadrant. That's where cos is positive. So sine in that quadrant is obviously negative. Then obviously we say sine of the trig ratio itself, and then the acute angle, was 360 minus falls away because it's accommodated by the sine of that particular trig ratio in that quadrant. Then cos, we do the same thing. We said 180 minus theta is in which quadrant? That's correct. It's in the second quadrant. Cos is negative in that quadrant. So we write cos theta whilst 180 minus falls away. 180 plus theta is in which quadrant? 180 plus theta is in the third quadrant. You're correct. Whilst we write sine negative because 180 plus in the third quadrant, cos is actually negative. Then we write cos of the angle theta, which is the acute angle. Cos 360 minus theta is in the, you're correct, it's in the fourth quadrant. How is cos in that quadrant? It is positive. So cos in the 360 minus falls away, accommodated in the sine, and theta is the acute angle that we write. And last but not least, our last trig ratio for the same function value, 180 minus theta. 180 minus theta is in the, yes, you're correct, it's in the second quadrant. How is tan? It's negative in that quadrant, so we write negative tan theta. 180 plus theta is in the third quadrant. Tan is positive, so we write positive tan theta. Then last but not least, tan 360 minus theta. 360 minus theta is in the, yes, you're correct, it's in the fourth quadrant. How is tan there in that quadrant? It is, yes, indeed, it is negative. So we write negative tan 360 minus falls, we write tan theta. Now moving right along to, from the function values, we look at what we refer to as our co-ratios. Co-ratios are unique in that something happens with the trig ratio if it is sine and there's a co-function of 90 plus 90 minus, sine changes to cos, cos changes to sine. So that's unique only with the 90 plus and the 90 minus. We also extend that to the 270 plus and 270 minus. So you could almost say that when we look at 90 and 270, okay, the 90 and 270, well, that's 90 minus, which is in the first quadrant, and 90 plus, which is in the third quadrant. We know that we use co-ratios. 90 plus, 270 minus, or 270 plus, that is also applicable. That's where sine changes to cos, and if it's cos, it changes to sine. So what we do is we do the same thing. Sine of 90 plus theta is in which quadrant? Second quadrant. How is sine in that quadrant? It is positive. Then we change the sine trig ratio to cos, and then 90 plus falls away because of the change that has happened on the sine, and then we write cos theta. Same thing, sine 90 minus theta, which quadrant's in the first? How is sine the first quadrant? Since all trig ratios are positive, sine is also positive. Then we write the co-ratio, which is cos theta. Then sine of 270 minus theta, no different. We say 270 minus theta is in the 270 minus theta is in the third quadrant. How is sine there? It is negative. Then we write the co-ratio, which is cos theta. 270 plus theta is in the fourth quadrant. How is sine? It's negative. Then we write the co-ratio, which is cos theta. So this is the repetition. We do this with cos, and it should be able to successfully give us the answer with cos as well. 90 plus theta is in the second quadrant. How is cos in that quadrant? It's negative. So write negative sine theta. 90 minus theta is in which quadrant? It is in the first quadrant. How is cos there? It's positive. So we write positive sine theta. Cos 270 minus theta is in which quadrant? 270 minus theta is in the third quadrant. How is cos there? It's negative. So we write negative sine theta. And last but not least, cos 270 plus theta is in which quadrant? It is in the fourth. How is cos there? It's positive. So we write positive sine theta. You may note that we have not written tan for the co-ratios, and that is because tan, we don't really look at the co-ratio of tan in this particular syllabus, and that's very important to note, and I hope it's clear. Okay. Then there are special angles, of course, special angles that can be done with no particular problem. Then there's one more thing that I need to look at, which I feel is of grave importance, and that is what we now need to look at is we need to look at negative angles, because whenever we have negative angles, what do? When we have negative angles, we add 360 degrees to that particular function value, whatever it is, because it's an angle that's a negative angle. We add 360 to the function value until we get a function value within the confines of a single revolution, meaning from 0 to 360, in other words, from 0 to 360. Okay, hope that makes sense. So yeah, alright, so we always add 360. Then for angles greater than 360, what do? We do the opposite. We subtract 360 until we have the 0 to 360 situation with our function value. So I hope that's clear. Alright, now let's go quickly look at some few examples so that you guys can learn to appreciate what we mean by all of this addition and subtraction and so forth. So here's the first question. We need to reduce sine of theta minus 180. Now it's very evidently clear that this negative 180 is a negative angle. So what we need to do is do what? We need to add 360 degrees. Hopefully you guys can see that we need to add 360 degrees. Now we can do this in a calculator, we don't have to actually do it manually. But if you add 360 degrees to minus 180, what do you get? Positive 180. So this is supposed to be sine of theta plus 180 degrees. But then you rewrite it. Okay, because 180 here is positive. Theta is positive there. So now that we actually know that addition is commutative, 180 plus theta is in which quadrant? It's in the third quadrant. Sine is negative, so we write negative sine of theta. Okay, so you add 360 until you enter into the interval of 0 to 360. In this case, we entered into that interval with having positive 180 plus theta. Okay, yeah, hopefully that's very clear for us. Maybe let's look at another one, angle greater than 360. So in other words, we are going to subtract 360 until we enter into that 0 and 360 zone. It only takes one subtraction actually of 360. That then puts us at what? Cos 360 degrees minus theta. Because remember, what did we do here? We subtract 360 degrees. We do that to the original, and then all we do is we just write down the function value that's now in the 0 to 360 interval. Then 360 minus theta is in the fourth quadrant. How is cos? It is cos theta. Okay, and it's positive. Okay, yeah, I hope guys you can see this. Okay, same thing here. Angle is negative 540. So what are we going to do? We are going to add 360. If it doesn't work the first time round, we'll add again. But if we add 360 to this, you can get an answer. Okay. Yeah, negative 180. We get negative 180, so we need to add 360 again. So if we add 360 once again, we get positive 180. So now we added 360 two times, we get positive 180 plus theta. Okay, you add 360 the first time, you get negative 180. You add 360 again, you get positive 180. And it's this 180 plus theta that I'm going to evaluate. 180 plus theta is in which quadrant? It is in the... Yes, you're correct. It's in the third quadrant. How's time? It's positive. So guys, this is how we do this. Okay, this is how we do these. Okay, and just one more. Cos 180 minus theta. 180 minus theta is in which quadrant? It is in the second quadrant. How is cos? It's negative. So we write negative cos of theta. Okay. Here's another one. This angle is negative 180. It's negative. So what do? We add 360. We add 360 the first time, we get sine of 180 degrees, but theta is still negative. Then 180 minus theta is in which quadrant? Second quadrant. How is sine? Sine is positive, so we write sine of theta. Okay. Let's check out another one. Theta minus 30. So we add 360. When we add 360, we get 0. So in other words, when we get 0, what do we get? Tan of an acute angle, which is theta. So that's done and dusted. No evaluation needed, because when we add 360, we just get theta. So we just write tan theta. Okay. Here's another one. Cos of a negative angle. What do? We add 360. So in other words, this would be like saying 360 degrees minus theta. When you have 360 minus theta, because what did you do? We add 360 when an angle is negative. So 360 minus theta is in the fourth quadrant. So we simply say, how is cos there? Cos is positive. So we write positive what? Positive cos theta. Guys, I'm going to hold it right there. But these are the other problems maybe that you can try and do on your own. Number 3, number 5, number 7, please screenshot. Number 8 as well, please screenshot. So those should at least kind of put you a bit on your toes, and you can do what needs to be done. Thank you.